It's day 24 of the advent of compiler optimization. We're going to look at probably my favorite optimization that I've ever spotted a compiler doing today. I hope you enjoy it. This is one of those optimizations that I stumbled over, and I can't quite remember where and when I first saw it, but it blew my mind when I saw it, and I'd like to share that feeling with you. So I'm going to go through a fairly silly thing, and along the way we should see some interesting optimizations. I'm going to write a function that returns the sum of values from 0 up to n. So this is like a sum of ints long x. So we're going to say for long I equals 0, I is less than x plus I, long total. I mean, all of my examples have been totals of sums. I know it seems very boring, but like there's just so much to this subject. Let's try and do total plus equals I. Return total, and we're in GCC and we've got Skylake architecture on and O3, so we're asking it to go to town adding up the numbers between 0 and x. And we can see on the right hand side GCC has done a fantastic job of doing some clever tricks here. It's saying, if it's less than 5, then go to L8. This, tons and tons of code on the right hand side here with vectorization going on, anding and extracting and adding, and we can be assured with this level of complexity that GCC is producing probably the fastest possible way of outputting the sum of integers between 0 and x, right? It's doing vector operations. I've no idea what it's doing, honestly. I trust it. I'm sure it's right, and it looks super fast. Or so I thought until I compared what it's doing with what Clang does. Let's select Clang 21 x86, and we see that the code has significantly reduced in size. And in fact, if you look harder, there is no loop in Clang's code. Amazingly, Clang has read through this and has inferred that it doesn't need to loop. How is this possible? Let's sort of work it through, and I'm going to hand wave. The full derivation is in the blog post that accompanies this. And for those of you who know the kind of thing that it might be doing, obviously you've probably already seen what's going on here. So the first thing we're saying is if the input value is less than or equal to 0, the answer is 0. We know that that's true. X could be 0, X could be minus, negative. So we just need to deal with that, and at that point we would just return 0. Otherwise, we're getting x minus 1 and x minus 2. We're multiplying it together, shifting it down, and then adding it to itself. RDI plus RCX. So RCX is the version that's been shifted down. RDI is the original version, and then we're decrementing it. That is crazy. If I change this to be integers, which will make it a little bit easier on our eyes, because this is the blog post does it in terms of integers, then we'll see maybe a slightly easier thing to reason about. Not really, no. I was wondering, I normally I do this with ints, and I chose to do longs while I was recording. Never change your mind while you're in the middle of doing a whole bunch of recordings. But it was the last day, so I had to do something a bit crazy and set myself up for a fall. But yes, here it is. We're multiplying x minus 1 with x minus 2. We're then dividing it by 2, and then we're adding it to itself at the beginning. RDI is adding it to itself and then decrementing it. So if you work that through, this is like n minus 1 over 2. It is the closed form solution of the problem. What is the sum from 0 to n? And this just naturally falls out of one of the internal implementations of Clang, the way that it tracks induction variables, the things we talked about many episodes back, and some other clever things that it does. It just notices this, and it kind of infers and implies and pulls this out, and I just love it. I love that this is some kind of I can only presume emergent behavior, and I'm not sure it's necessarily great that it's doing this. It is great because I'm enjoying talking to you about it, But in general, I'm not sure that this is a valuable thing to happen. Maybe there are some routines that would benefit from this. I don't know, but I love it, and I just think it's amazing what compilers can do. And so that's when I'm going to end the series of compiler optimizations. There will be an episode tomorrow, but it'll be a bit different from the other episodes. I still look forward to seeing you tomorrow.